Hello everyone, I'm excited to share a geometry problem from Iranian Geometry Olympiad of 2023. It is also called as IGO 2023. Usually Iranian Geometry Olympiad is considered one of the difficult geometry contests all around the globe. This is related to math Olympiads and we will do some area chasing as well as we will be using the idea we derived for a parallelogram when the perpendiculars are dropped from its vertices onto a random line outside the parallelogram. So if you would recollect that, the sum of perpendiculars from opposite vertices of a parallelogram are equal to a line drawn outside the parallelogram. I also urge you to look into the earlier video about this property, and this will be very useful to tackle the problem. Let's get started. Here is the problem statement. We will parallelly draw the diagram to understand it clearly. This is the problem number 2 of IGO 2023 in advanced level. They have considered a triangle with incenter. What is an incenter? Incenter is the point of concurrency of internal angle bisectors of a triangle. One may also visualize this as the center of circle inscribed into the triangle, but that's just equivalent. Here it is sufficient to think it of as a point of concurrency of three angle bisectors. And BI and CI intersect opposite sides at 2 points, and M is the midpoint of the arc BAC of the circumcircle of the triangle. Let's look into its diagram. Here is the diagram, and as you could see, the point M is the midpoint of the arc BAC of the circumcircle of the triangle. That just means the point M such that BM arc equals CM arc. Equivalently, the chord BM equal the chord CM. So, of course, then this point M would lie on the perpendicular bisector of BC. Alright, we will not need that necessarily, but we will need the property BM equals CM. So by this property, notice that these two angles at B and C are equal as it is an isosceles triangle. Now BAC angle equal BMC as both of them are subtended by the arc BC on the other part of the circle. So the angle subtended by the arc would be the same on the circle, therefore it is A. Now the other two angles are equal, so each of them would measure 90 minus A by 2 and 90 minus A by 2. This is also a way to define the point M. That is the point such that it makes angle 90 minus A by 2 with BC on both B and C. Let's write it down. Angle MBC equal angle MCB equal 90 minus A upon 2. Alright. So we have defined M in a concrete way. So let's proceed. Suppose the quadrilateral MXIY are concyclic, and as mentioned, X and Y are the feet of the angle bisectors onto its opposite sides. You get MXIY points to be concyclic, and that is highlighted in this red colored circle. This does not happen for any triangle, but the triangle is chosen in order to accommodate that. So the measurements and everything is conducive to this particular problem statement. Now prove that the area of quadrilateral MBIC. So let's draw that. Quadrilateral MBIC equals area of pentagon BCXIY. So BCXIY would be like this. These two areas are equal. Initially it might seem a random type of area that cannot be related directly, but you can add a particular area that sort of makes them both lie on a common base, and that will be easy for our measurements and calculations. So the yellow shaded area equals the area shaded in violet. This is the question. Now let's take a look on how to manipulate this in a better way. Because without a proper goal or target to prove, you cannot attempt the problem better way. Because you should be aware of the prospective outcome of the process that you are applying in your solution. So first, I will consider the area BCXIY, and we also have the area MBIC. Something is sort of missing in the picture, that when fitted, will turn into nice configurations. What is that thing missing? For example, if you take MBIC, if you fit in BIC triangle, you would form a nice triangle MBC whose properties are very much clear to us. That means let's try attaching BIC to both of these areas, one for pentagon and other for the quadrilateral. First, for the pentagon, if I attach BIC, would it render something useful? You see, BCXIY can be splitted into area of BXC plus area of BYI, and the BIC area will add on top of that, which we added intentionally. So now BXC will still remain the same, that is a nice triangle, but we will try converting BYI plus BIC to a larger triangle, that is BYC. So now you could see that this is sum of two triangular areas and that can be easily handled. Let's compute the other part. You have MBIC and when added with BCI area, it's clearly MBC. Therefore, it is required to prove that area of MBC equal area of BXC plus area of BYC in order to complete the state problem. There is also something nice happening here. All of these triangles have something in common. Can you predict what it is? The triangle MBC, the triangle BCX and the triangle BCY have the side BC in common. All of them sort of sits on the side BC, right? So what if I express their areas in terms of that side length BC and the height corresponding to that base? So area of MBC can be perceived as half times the length of perpendicular from M to the side BC, called HM times BC. So we get half into HM times BC. This is equal to, you drop a perpendicular from X to BC, call it HX. So area of BXC would be half HX into BC, and drop a perpendicular from Y to BC, the length would be HY, half HY into BC. You see that half BC is common with all these expressions, so it just remains for us to cancel them. Therefore, in order to prove the problem statement, it is equivalent to proving that HM equal HX plus HY. But wait, we have realized this equation somewhere else, right? And this is exactly what I mentioned in the introduction as a preliminary theorem, that when you drop perpendiculars, let's draw a diagram to illustrate it. Suppose you have a parallelogram and also you have a line outside the parallelogram. Call the vertices ABCD. Then drop the perpendiculars from the vertices of the parallelogram onto that random line outside the parallelogram. Let HA be the length of perpendicular from A. Similarly, HB, HC and HD can be defined. Then it turns out HA plus HC equal HB plus HD. And that is exactly what this configuration reminds me of. This configuration along with the condition that we require to prove. You see, the perpendicular all lie on a line BC from 3 vertices. So that means if I am able to prove that the 4th vertex of the parallelogram is on the line BC, then you will get the perpendicular height to be 0 and you will get HM plus 0 equal HX plus HY, which will complete my solution. And this is exactly what motivates me to construct a parallelogram with vertices M, X and Y and another vertex, say Z. So therefore, we are now going to construct a parallel line to MX through Y to intersect BC at a point Z. Let's take a closer look. So consider MX, the line MX, and I'm going to construct a line parallel to MX through Y to intersect BC at Z. Then notice that I should prove that MXZY is a parallelogram, because it should be, right? the height conditions just exactly satisfies that parallelogram condition. So if this is the point Z, then I try to prove that My is parallel to xz, and that's it. If you are able to prove this, then you will get that mxzy is a parallelogram, and the height from M plus height from Z, which is 0, which is hm plus 0, equal the height from x and y, that is hx plus hy. Now this in turn proves the area condition with BIC added, and then you can cancel BIC, and that directly takes you back to the original question asked. So we will try to prove the simple idea of My being parallel to xz. But how to think about the point Z? Let's chase some angles here. If I construct such parallel lines, I try to prove some weird concyclicity. But it is not difficult, it is easy. If you try it for some time, you will be able to prove this. I try to prove that MCZY is a cyclic quadrilateral. Let's do that. Notice that MCZ is 90 minus a by 2. And also BIC is 90 plus a by 2. That's because just it is the incenter, and these two angles can be represented as B by 2 and C by 2. So this one, BIC, must be 90 plus A by 2. Simple. And therefore, angle XIY would be 90 plus A by 2. And now, if you think about the angle XMY, it is supplementary to the angle XIY, as the 4 points are concyclic. So angle XMY equal 180 minus angle XIY, and that in turn is 180 minus 90 plus A by 2, which is 90 minus A by 2. The point Z is constructed in such a way that YZ is parallel to MX, and that means this angle would be 90 plus A by 2. So angle MYZ would be supplement to the angle YMX due to the parallel lines. And that's it. We get angle MYZ plus angle MCZ equal 90 plus A by 2 plus 90 minus A by 2. Both add up to give you 180 degrees. This means the quadrilateral MCZY is cyclic. Alright, this is proved, and it is also simple angle chasing. Let's now think about some other 4 points. If I talk about MYZC to be concyclic, and if it is going to be true that My is parallel to XZ, then by a symmetric argument, I should also obtain MXZB to be concyclic. And I take the back way argument that if they are concyclic, I will now prove that My is parallel to XZ. You see, these two being parallel made a concyclic quadrilateral. Now, if the statement My is parallel to XZ is true, then it will also be true that MXZB is a cyclic quadrilateral. And let's try to prove this and approach the required statement of My parallel to XZ in a backward direction. So now let's chase the angle MCY. I know this entirely is 90 minus A by 2, MCB, but 90 minus A by 2 is B by 2 plus C by 2. And therefore, the angle is B by 2 because YCB is C by 2, because CI is the angle bisector. So MCY being B by 2 implies MZY to be B by 2 due to the concyclicity. Now MZY is B by 2 and MX is parallel to ZY, therefore XMZ is B by 2. And thus we got something nice, angle XMZ equal B by 2, which is also equal to angle XBZ. So some angle chase again. XBZ is B by 2 because BI is the angle bisector, and that forms another cyclic quadrilateral, that is MXZB is cyclic. So we got two cyclic quadrilaterals. Now let's try to prove that My is parallel to XZ using the cyclic quadrilaterals we have obtained. So here are the two cyclic quadrilaterals we derived that are being annotated with the dotted lines, and we are in our way to prove that My and XZ are parallel. let's think about this angle MYZ. I know that MYZC or MCZY is a cyclic quadrilateral. With MCZ being 90 minus A by 2, therefore MYZ would be 90 plus A by 2. And then let's chase the angle XZY, this one, XZY. Angle XZY would be 180 minus of angle ZXM, because we assumed YX and MX are parallel, YZ and MX are parallel. So let's try to find angle MXZ. Angle MXZ is nothing but 180 minus of angle MBZ, because the second cyclic quadrilateral implies opposite angles are supplementary. And angle MBZ is just angle MBC, as BZC are collinear. MBC would be 90 minus A by 2, which renders angle MXZ to be 90 plus A by 2. So this is 90 plus A by 2, and therefore angle XZY is 90 minus A by 2. Now that's it. You could see that angle MYZ plus angle YZX equal 180, and this renders the lines MY and XZ are parallel, and this proves that it is a parallelogram, and therefore you have HM plus 0, because Z lies on the line itself, equal HX plus HY. Now again you relate to the areas, and the areas of MBC and BCX plus BCY, and then remove BIC, and you will get the required two areas are equal. So the key aspect here is the motivation to think about the point Z. But what's the motivation to think about the point Z? It is the property that perpendiculars from vertices of a parallelogram to a line are equal, because that gives me an intuition that the point which forms a parallelogram with points MX and Y is going to lie on BC, and therefore we started researching about that point and digged deeper about it. So that's one main reason I urge my students to learn about important configurations and ideas beforehand that are fundamental. For example, the perpendiculars from parallelogram is a fundamental property here. That is the crux of this question, I would say. So this is a advanced problem. You can also try other level problems from IGO. They are of good difficulty level. Happy learning everyone. Thank you. Bye.